So hopefully by now you've done a review of multiplying polynomials, especially multiplying binomials times each other, and also a review of factoring when the lead coefficient is equal to 1. And I usually kind of call that the easy way because it's just one step, right? We look for our factors of the C term, add up to the B term, and then put them in brackets. That's it, okay? What we want to do is we want to look at things that are a little bit more complicated now. Okay, and hopefully you've had time to let the basics of factoring kind of sit in your brain and you know, percolate a little. We want to add a couple of extra steps. The factoring that we're going to do in this lesson is the hardest factoring that we do in grade 10, but it's also really important because most of the factoring, most of the quadratics we run into in grade 11 and grade 12 have a lead coefficient that we can't just factor out. Okay, we have to work with it. We have to see what's going on. And I think the easiest way to kind of understand the steps that I'm going to show you is to show you how it fits with multiplying. So let's take a look at this example right here. I've given you a FOILing question, right? We've got a binomial x minus 5, and we're going to multiply it by this binomial 3x plus 2. And I'm going to the boxes. I quite like that method. I'm going to do it kind of by FOIL, for just so specifically we can kind of look and see, and we can compare this work that we're doing to the factoring that we're going to do in our notes in a second. Okay, so I'm going to start by, you know, let's just remember what FOIL means. And it's just an acronym to help you remember what's going on. It just describes the fact that we have to distribute each term across each term in the other binomial. Okay, so it's just to kind of help you remember. It's not really a verb, I just kind of use it that way. So let's take x times 3x squared. So let's do that one first. So this is the first one, right? So x and 3x, these are our first. So x times 3x, right? And then our outside terms is x times 2, which is 2x, and our inside terms, which is, you know, minus 5 times 3, which is negative 15x, and then our last, which is minus 5 times 2, which is minus 10. Okay, so this is our in-between step, and then what we want to do is we want to collect our like terms and then simplify this, because we've expanded and now we want to simplify, right? So let's combine our like terms here. So 3x squared, 2x plus 15x is negative 13x and minus 10. Okay, so if we were going to expand, and I'll just get rid of some of these lines so we can see this work a little bit better. If I was going to expand and simplify those two binomials, I would go from this to this with this kind of in-between step. Now, hopefully that's very familiar to you, and it's I really want you to kind of take a look at what we're doing here, and we'll come back and we'll look at this and we'll compare it to what happens when we work in the other direction. Okay, so this is what the page of our notes looks like that we're working on. We're going to kind of if you have old notes, I know sometimes you guys borrow notes from people who did this work in last semester. We're not doing quite as many lessons as we would have done last semester because, you know, last semester they didn't have to deal with a global pandemic. So this is the first lesson we're going to do in this unit. We're going to factor quadratics with a lead coefficient greater than 1. And before we do that, it's going to be really helpful if we remember that a quadratic looks like this form here. That's a quadratic expression. ax squared plus bx plus c, right? We always have a degree 2 term. We have to have this term. A can't be equal to 0. B can be equal to 0 and c can be equal to 0, but we have to have a degree 2 term here. Okay, so this is what our quadratics are going to look like most of the time. Okay, and so A, B, and C are just numbers. So a quadratic with a lead coefficient greater than 1, we've seen these before. We've seen examples where, you know, maybe we had 2x squared plus 4x plus 6, right? And what we were able to do is we were able to factor out that lead coefficient right there. What we want to look at now is what happens if we have a lead coefficient, right? If we have an A value that's bigger than 1, right? So we can see a number there, but we can't factor it out because it's not a common factor like this 2 is, right? This 2 is common to 2, 4, and 6, and we could factor that 2 out, right? And we could, kind of factor this guy further. Well, actually, we can't factor that guy, because that guy doesn't factor. I made up something that doesn't factor. Factored, right? We would have been able to just factor it kind of that easy way, because our lead coefficient would have been 1. So what do we do if we can't factor that lead coefficient out? We still need to be able to factor it. So we need something that's going to have that's going to help us deal with that lead coefficient. So we have this kind of 5 or 6 step process that this strategy is called decomposition. Now, there is more than one way to factor these, and some of you might actually see a pattern where you can factor this without following these 5 or 6 steps. The 6th step is just to check your work, but if you can consistently factor these things in a different strategy, if you kind of just see what's going on, and some students get really good at this, then by all means, you are more than allowed to do that. I'm going to show you decomposition because even though it looks very long and very complicated, once you kind of get a hang of the steps, it works every single time. Without a doubt, it works for everything. You don't actually need to know another way to factor. If the only thing you know is decomposition, it will always work. It's not always the best strategy, but it will always work. Okay, and I like to have a good backup plan strategy, right? Something that's, might be a little bit complicated and a little bit long, but it always gets me to the right answer, especially if I can't see a better strategy right away. Okay, so the only time I'm recommending you use this strategy is when you have a lead coefficient greater than 1. That's not a perfect square, okay, or that doesn't have perfect squares, and that'll make a little bit more sense later. Okay, so let's take a look at this first problem. Well, first here, I'll read you the steps. First step is we want to multiply the A and the C values together, and then we're going to make a list of those products factors. Okay, so that's actually, we've done that before. We've made a list of the factors. Okay, we're gonna do that this time. We're gonna look for the pairs of factors that add up to the B term. Okay, so that's the middle term. We're gonna look for the pair that adds up to the middle term. That's another step that's familiar. Okay, so this one's a little bit different. This is a little bit different, but the second step is we should be used to it. The third and fourth steps are new to this process. We want to, once we found a pair that adds up to B, we want to rewrite that B term using those 2 numbers that we found in the previous step. We're going to factor out the greatest common factors from the 2 binomials that we created, and I'll show you what that looks like in a second. And then we're going to collect our binomial factors. This looks very complicated. It's not terrible, I promise. Okay, it takes a little while at the beginning, and then we get used to it. All right, so let's take a look at our first example here. Pause the video and copy these notes if you want, so then you can kind of follow along with what I'm doing. All right, let's factor this guy. So we have 3x squared minus 13x minus 10. There are no greatest common factors here. There's no number that goes into 3, 13, and 10. So we can't factor out that 3. So because our lead coefficient is greater than 1, we need to factor this guy using decomposition. Okay, so step 1, multiply A and C. So A equals 3. Okay, sometimes the video freezes, so if this sounds weird and I'm repeating stuff, I'm sorry. Okay, so multiply a and c. So a equals 3, c equals minus 10. So my product here is minus 30. What I want to do is I want to make a list of the things that multiply to minus 30. Well, 1 and 30, 2 and 15, 3 and 10, 5 and 6. And we want the pair that's going to add up to minus 13. Okay, so be careful because it looks like we're going to use the 3 and the 10 here, but we're not. We need to use the 2 and the 15 because only one number can be negative because we're multiplying to negative 30. So if we have a negative 15 and a positive 2, that will multiply to minus 30 and it will add up to minus 13. Okay, so this should look pretty familiar so far to what we've done before. The only thing that's different now is we have to multiply these guys together to make that 30. Okay, before we just looked at the c term. Now we need to multiply that c term by the a term first. Okay, so we've got this 2 and this minus 15. That's step 1. Step 2, look for the pairs of factors that add to b. So we did that. We found the pair of factors that add to b. Step 3, rewrite the b term using the factors you found in 2. So this is where the name of the strategy comes from. Decomposition means to like break down, right? Decompose. So we're going to take this middle term here and we're going to break it down. We're going to rewrite it into something different. So the 3x squared stays the same. But instead of 13x, we're going to do this with our plus 2 first, 2x minus 15x minus 10. Okay, so do you see what we did? I took my minus 13, and instead of calling it minus 13, I said, well, it's a plus 2 and a minus 15. So I kept the value of it the same. I'm just writing it in a different form. So I took my trinomial, and I turned it into a polynomial that has 1, 2, 3, 4 terms. Okay, so that's step 3. Step 4 says factor out the greatest common factors from the 2 binomials you created. Well, here's our 2 binomials. This one and this one. Okay, so what we want to do is we want to kind of break them into those 2 chunks and find the greatest common factor of each chunk. So what's the greatest common factor of 3x squared plus 2x? Well, it's x. It's the only thing they have in common. And when we factor it out, we're left with 3x plus 2. Okay, and then we look at our second pair. What's the greatest common factor of negative 15x and minus 10? Well, it's minus 5. And when we factor that out, we're left with 3x plus 2, right? Because negative 15 divided by negative 5 is 3. Negative 10 divided by negative 5 is 2. Okay, so that's what we're left with. Now this looks a little bit weird until we notice that our brackets, what's in our brackets is the same. That's a very good sign, okay? That means we did this step right anyway. We did the factoring step right, okay? So now what we do is we collect our binomial factors. So what's outside the brackets becomes one binomial, x minus 5 becomes one binomial, and then what's inside the brackets is the other one. Okay, and now this is our factored form. We have a binomial times a binomial. Okay, and hopefully that looks a little bit familiar to you. Hopefully it looks like what we did in this problem here, which is really big and really hard to fit on the screen altogether, apparently. Okay, so what I want you to do is I want you to notice how our product turned into our quadratic and how our quadratic turned into this product of binomials. And look at this in-between step. Look at this 3x squared plus 2x minus 15 minus 10. That's the same as this 3x squared plus 2x minus 15x minus 10. Okay, so hopefully you can see how they both fit together. Okay, hopefully that makes sense. All right, let's try the next one. All right, yeah, let's try the next one. This one's a little bit tricky. So let's see what's going on here. Zoom in a little bit. Lead coefficient is 36. It looks a little bit odd because we have two variables. We have an x squared, an xy, and a y squared. This is sometimes what we see when we factor quadratics. So the easiest way to tackle this guy is through decomposition. Lead coefficient is greater than 1. This it doesn't look like a quadratic, but it is. So we're going to multiply a, which is 36, times 1, which is 36, and we'll list the factors of 36. 1, 36, 2, 18, 3, 12, 4 and 9, 6 and 6. And which of these pairs adds up to 12? Well, that's our 6 and our 6. So we rewrite, instead of writing 12xy, we write plus 6xy plus 6xy plus 1y squared. Okay, so that's our decomposition step. We broke this 12 up into two different pieces. So that means we have a binomial there and a binomial there. And we're going to factor the greatest common factor from both of them. All right, the greatest common factor of 36x squared and 6xy is 6x, which means we're left with 6x plus y. Okay, if you have to, go back to the first number sense in algebra book and look at how we factored greatest common factors, and go back and do that practice work, especially if you're going on to pre-cal next year. This is really important. Okay, and then our second pair, we have 6xy plus 1y squared. The only thing they have in common is y. So we're going to put a plus y there because it's positive. And we're left with 6x plus y here. And thankfully what's in our brackets matches, so we did this step correct. We collect what's outside our brackets, 6xy, oh sorry, I did that wrong, 6x plus y is what's outside our brackets, and what's inside our brackets is interestingly the same, 6x plus y. Okay, there's actually a better strategy to use for this problem that you'll see in the next lesson, but this is a good way to show you that decomposition will always work. So it's a really good strategy to have in your toolbox. All right, I'm gonna actually I'm gonna make this one just a little bit easier. It has a greatest common factor. I don't know if you can see that right off the bat, but 3 goes into each of these numbers. If I factor out the 3, I'm left with 2x squared minus 7x plus 3. Well, okay, we'll work with this one. We'll work with this one. So we factored out a greatest common factor, but we still have a lead coefficient greater than 1. So we still need to use decomposition, right? Because we can't factor that 2 out of each of these guys, because 7 and 3 are odd numbers. Okay, so what we want to do is we want to keep the value of that 3 in our work, but we're not going to, it's already factored out, so we're just going to kind of keep it in front of everything. All right, so let's take our 2 and our 3, because A is 2 and C is 3. So when you multiply that together, we get 6. Factor the 6, and we look for the pair that adds up to -7. Well, -1 and -6 multiply to +6 and add to -7. So that's our pair. So we're just going to keep that 3 in front of all of our work. It's already factored out. We don't need to do anything more with it except carry its value down with us with each step. All right, so we've got 2x squared, and instead of writing minus 7x, we're going to write minus 1x minus 6x plus 3. It really doesn't matter at all if you wrote 2x squared minus 6x minus 1x plus 3. The order of these two don't matter, right? they would still combine together to make -7. The only thing that would be different is what's inside your brackets and what's outside your brackets would be different depending on the order of this, but we'd all end up in the same place. So you know what, I encourage you to, try this question the other way around, or at the end, do this question again, but instead write the 6x before the 1x and see what happens. Okay, so let's leave the 3 in front, and now let's factor the first pair and the second pair. Now this little bar that I'm drawing here is not a thing. It's not a math thing. It doesn't mean anything. It's just me trying to show you the first 2 binomials and the second 2 binomials, and it kind of helps us kind of visualize what we need to do next. Okay, so it's not a necessary step. Don't worry about that. It's just kind of how I'm trying to show you what's going on. So let's find our greatest common factor of 2x squared minus 1x. So that's going to be x, and we're left with, when we factor it out, 2x minus 1. And our greatest common factor of -6x and 3 is -3, right? Because remember, that habit that I tried to get you to, to work on was always factor, whenever this lead thing that you're factoring from is negative, you always want to factor the negative out. So because we're factoring first from -6, I want to factor out the negative. Okay, and then we're left with 2x minus 1, and our brackets match, which is perfect, and we still have that 3 in front. So we've got lots of brackets here. It's a little bit easy to lose track of them, but you can just watch for that. Okay, so the 3 still goes in front, and we collect what's inside our brackets, 2x minus 1, and what's outside our brackets, x minus 3. And again, the order of those don't matter. Sometimes I don't know, I don't even have a way that I do it all the time. So if you would have just gone 3 and then x minus 3, exactly the same answer. Okay, so the order of these factors don't matter. Okay, so my laptop has frozen a million times during the making of this video, so I hope that it makes sense. I hope that it's coherent. I'm giving you guys another resource to look at in terms of factoring this way. I encourage you to look it up. The strategy is called using decomposition. So if my words and my video don't make sense, please go find this in a different source. And you might find some different strategies that people use. There's a box method that some people like, and there's, kind of logically reasoning your way. And again, I'm very comfortable with you doing whatever strategy works for you. Okay. However, some of those other strategies are really difficult when there's lots of factors involved. They work really nicely for some numbers, but not for other numbers. So try this guy. Let me know what questions you have. I can always make another video that shows some of the practice questions kind of worked out too. Okay, so hopefully this is going to work for you guys.